let's look at an example question. So our objective is we're trying to solve the system of equations. So this should have an S on the end. And here are my equations. So here's the first one and here's the second one. So we're given two equations and we want to find the point, the xy coordinate that satisfies both of these equations. So let's look at this, and we're doing this through graphing in this video. So there's multiple methods, but we're going to choose the graphing method. So the first thing, let's graph y is equal to x. Well, this is a graph that you should recognize. But let's go through the method of solving using graphing, setting it up using a table of values. So the inputs, I can choose anything, so I'm going to choose -1, 0, and 1, and I solve for my outputs. When x is -1, my y is -1. When x is 0, my y is 0. And when x is 1, my y is 1. So let's graph that. -1, -1, 0, 0, 1, 1. And we get the graph that we should recognize of a line that splits the first and the third quadrant in half. Alright, my first step, I graphed my first equation. My second equation, let's graph that now. And we'll do it the same manner. Graphing using a table always works. So let's do this one in blue. So for my x variable, my y variable, my x variable is my inputs, and I can choose anything, but if I look up here, let's strategically choose a -3, and let's choose a 0, and let's choose a 3. Now I chose a -3 because you'll see it causes the y to work out evenly. So when I plug in a -3 here, well, -1/3 times a -3 is equal to a +1. So 1 plus 4 is 5. Now if I have 0, that would cause this whole thing to be 0. 0 plus 4 is 4. Let's do this one mentally. -1/3 times 3 is -1. -1 plus 4 is +3. So let's graph this out. When x is -3, -1, 2, 3. My y is 5. 1, 2, 3, 4, 5. When x is 0, y is 4. 1, 2, 3, 4. When x is 3, 1, 2, 3, my y is 3. 1, 2, 3. And when we graph this, we get this line. Alright, you might be thinking to yourself, Mr. Phillips, why did you go through all that work and set up an XY table? I know that this value right here is my y-intercept, so I could just graph that right there on the y-axis. I also know that this is my slope, so I can rise a -1 and run a +3, and that's a -1 over +3, and there's my second point. And then you only need 2 points to make a line. Well, you're exactly right, so you can graph like that as well. Table of values is another way to graph. Alright, if you look at this, well, we just graphed both of our lines. And now what we're looking for is what value satisfies both of these equations. One equation represents all the solutions to a particular graph. So y is equal to x. These numbers that lie along here, if you look, -1, 1, or -1, -1, that lies on the graph. 0, 0, 1, 1, 2, 2. Well, all those satisfy this graph. But right here, the point of intersection. Point of intersection. I'll just put stacked. So it's the point of intersection. That is the solution to both of these equations. So let's look at what that value of that point is. So we look at that, we're going 1, 2, 3, 1, 2, 3, so this is at 3, 3. And this is my solution to both of these equations. So we can check that. Let's bring this down here. Was 3 equal to 3? Yes, 3 is equal to 3. That's pretty apparent. So that one checks. Let's do the blue one. We have y is equal to 1. Negative 1/3 times 3. So let's put 3 in for my y. Negative 1/3 times 3 plus 4. Well, that's 3 is equal to negative 1 plus 4. 3 is equal to 3, so that one works as well. So both of these check out, so this is my solution. Alright, just to go over and clarify the steps. Well, our first step is graph both equations. Second step, we are going to look for the point of intersection. And this is the solution to each equation. And the last step is very important. A lot of students leave this one out. The last step is always check your answer. We'll do that by substituting values into each equation. Okay, that's that. Check your answer, substitute values in each equation. These are the 3 steps. They're very important. So I'll have a harder example problem worked out on a separate video.